Hello. All right, we're going to do a problem from section 3.1, number 23. And what we're supposed to do is differentiate. When I see this, I see a fractional expression, quotient of two functions, and I think quotient rule. However, in section 3.1, they haven't done the quotient rule. We have a power rule, and that's what we're going to use. And in the future, sometimes you can avoid using the quotient rule and you can use this method, which will lead to the power rule. What we see here is on the denominator just a single term, and that's what makes this method I'm going to show you work. And see, what we're first going to do is we're going to write this fraction as three separate fractions, and that is done by using the definition of addition of fractions. When we add fractions, they all have to have the same denominator. And then we add the numerator. Now, when I break them apart, which I'm doing here, I do that method backwards. I have the same denominator, and I have the numerator broken up into those three pieces. So I have three fractions. Now, let me tell you why I'm doing this. Because what I want to do is I want to write each of these terms as a power of x. And then I will differentiate by using the power rule. This works because we only have a single expression here, square root of x, a single term, which is a power of x. Okay, if this are just a little bit different, like square root of x, that square root of x plus 5, it won't work. It has to be a single power of x. Now, one of the things maybe I should have done earlier or right away is not write this as a square root. So in a calculus class, and actually I think in a lot of cases, it's hard to see why we even want to write a square root, because when we differentiate, we want to write the square root of x as x to the 1/2. So the square root of x is maybe an easier way to read what x to the 1/2 is, but when I'm taking the derivative, I want x to the 1/2. Now, what I'm going to do is simplify this, because again, what I want to do is I want to write this as a sum of powers of x. And so on the side here, I had this already pre-written, that there's a rule for simplifying ratios of powers of x. If I have x to the m divided by x to the n, it's equal to x to the m minus n. Also, 1 over x to the n is x equals x to the negative n. Okay, so for this first one here then, when I write y equals, notice I haven't taken the derivative yet. I'm going to write x to the 2 minus 1/2. I'm not taking a derivative. All I'm doing here is I'm simplifying. And actually, I'm sort of showing a lot of work here. It's very tempting to do that subtraction in my head. But 2, I have x to what power? 2 is 4/2, so I have 4/2 minus 1/2, and I get 3/2. Moving on, I have 4 times x to what power? 1 minus 1/2, that's 1/2. It's 2/2 minus 1/2. And I have 3x to the minus 1/2. Now, what I'm going to do is I'm going to use the power rule to find the derivative. So the derivative is a noun. To find the derivative is differentiate, and that's a verb. It's a long word to spell out, so that is a problem in a way. Sometimes we just say find y prime, but anyway, differentiate using the power rule. It's important. Should I capitalize the power rule? All right. So I'm just going on to this line here where I have not yet, I didn't take the derivative, I wrote as sums of powers of x. Y prime is 3/2 x, 3/2 minus 1, plus 4, 1/2 x, 1/2 minus 1. Okay, briefly, okay, let me just keep going now. Plus 3, negative 1/2 x to the negative 1/2 minus 1. What am I doing? I'm taking the powers, x to 3/2. I'm taking the power and putting in front, and then I do 3/2 minus 1. Then I have 1/2 comes to the front, 1/2 minus 1. Okay, that's what's working here. I need to do that subtraction. 3/2 minus 1 is 3/2 minus 2/2, so that's x to the 1/2. So I'm essentially just, I'm getting the answer now. 4 times 1/2 is 2, and I'm simplifying. 1/2 minus 1 is 1/2 minus 2/2, that's x to the negative 1/2. And I'm coming up with something that looks pretty good. Negative 1/2 minus 1 is negative 1/2 minus 2/2, that makes negative 3/2. So the more you do these problems, the more you're going to, figure that out, get these. That answer is, this is a good answer. This is an answer. But the author, James Stewart, I think will write it differently. The author will, I believe we look in the back of the book, the author is going to write this as x to the 1/2 is the square root of x. I sort of don't think you need to necessarily, but we definitely should know how to do that. Before I do that, let's first move these powers of x to the negative 1/2. Let's move these so that we have a positive power, but that moves it to the denominator. And then I have a little note here that x to the 3/2 is equal to x to the 1 times x to the 1/2, because 1 plus 1/2 makes 3/2. And then x is x, and x to the 1/2 is square root of x. So this leaves that x prime is equal to 3/2 square root of x plus 2 over square root of x minus 2x square root of x. The thing is, my last line is a little bit messy. It's correct, but after all that, why don't I try a little harder to write it better? Okay, that is, I think, the answer that you'd see in the back of the book. Let's put an orange. Good color for orange is. Okay, but green's a good color too. Lots of colors are good. Red, white, and blue, and green and purple, and just all the colors. No special meaning. I just picked those colors. Okay, so there we go. So this is using the power rule and finding the derivative of a quotient, but not using the quotient rule. And that works because the denominator is a single term, single power of x. Okay, that is all.